Namaste, welcome back to Sthita Pragna channel, and you are watching AWS Projects Season 3 series. In this series, we have done 2 projects so far, and we are doing projects as data analytics role, as you can see here. And if you are interested in Season 1 and 2, Season 1 where we have done projects as cloud practitioner, and Season 2 we have done projects as solutions architect. So in this we are going to do projects as a data analytics role. So let's go ahead and get this bit. I think we are almost close enough. Which metrics can be tracked in a scaling policy? I think memory is not possible, so I think it is these 3. Yay! And yes, we have got Peanut. Peanut is impressed with your AWS knowledge and wants to be your friend. Thank you, Peanut. And we have plenty of pets, I assume, by now. So we have Mr. Honey, Bubbles, Zazzy, I think Crocky. He won't get easily impressed. He still needs 6 more questions to go. And we have all these friends by now. These are all 12. And I think pretty much we made most of this as friend. Take for walk. So when you do that, actually they will be right next to us. Yep. Looks like there is another, I don't know what I did there. Another pet right somewhere here. Okay, I don't want to do all that right now, but let's go into our project. Today's project is going to be querying the data lake. Remember, in the previous project we have created a couple of buckets and used them as data lake, and in this project we are going to query data lake. I am assuming we will be doing or using different AWS technologies to query from data lake. Okay, we entered data analytics island. As I said, there are different islands. I think on this island we will get all the projects related to data analytics. Hello there. I am glad to see our call for help has been answered. I am always happy to be of service. What seems to be the problem? Is it that pesky Y2K again? Ha 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 ha, no. We seem to have that handled now. We have a new issue concerning how best to handle some of the data that our financial institution is being asked to process. We recently set up a data lake to ingest data from providers all across the city. We receive everything from bank statements to tax information and credit card transactions. I see. Do you need help processing this data? I know data lakes can get tricky with the many different sources and the sheer amount of structured and unstructured data coming in. No, the data lake is working as intended. Our issue now is that one of the credit card issuers we work with has asked our fraud department to begin scanning for possible fraudulent transactions. Is this something you have experience with? Absolutely. I can help familiarize you with how to query the data. Can you tell me where this incoming data is being stored? The data comes in daily as a comma separated value file and it is saved to an Amazon S3 bucket. Great. This would be a perfect scenario for Amazon Athena. Athena is an interactive analytics service that makes it simple to analyze data in Amazon Simple Storage Service using SQL language. With a few actions in AWS Management Console, you can run on-demand queries and get results, usually within seconds. Your fraud department can query the data for suspicious transactions any way they see fit. I don't know. I hesitate to introduce more infrastructure for our teams to monitor and maintain. Actually, Athena is serverless, so there is no infrastructure to manage and you pay only for the queries that you run. Serverless is exactly what I like to hear. What can we do to get started? Alright, so that's the problem and he already provided a solution. Let's see what we are going to learn by doing this project. Query for suspicious credit card transactions, how to ingest CSV formatted data into S3, create Athena table that contains transaction data, and create Athena table that contains only suspicious transactions. So on left side, we are going to get Lambda Athena S3. So I am assuming we will use these 3 services. So let's accept. Wonderful. Let's get moving. As usual, we have our diagram here. On left side, we have videos. The videos you should be watching for this are Lambda overview and Athena overview. Go ahead to our playlist, which is AWS tutorials for beginners. You will have videos with the same titles. Go watch them, then come back and watch the remaining. So if we look at here, in this solution, AWS Lambda function generates credit card transaction data as CSV file and saves it to an ingestion bucket in Amazon S3 or here. And after that, the user runs a SQL query on the file using Amazon Athena to create a database table that contains the credit card transactions. The query results are saved on an S3 staging bucket, which is something you can see here. The user then runs another SQL query using Athena to search for suspicious transactions. The query creates another table and stores the data in the staging bucket. Same staging bucket, both the cases. Users in the fraud department create SQL queries and run them on the suspicious transactions table in Athena. These query results are also saved to the staging bucket. So you can see there are so many things that are going on. Transaction table query, suspicious transaction table query, and generate query results, fraudulent results, drop suspicious transaction query, etc. And then after the fraudulent transactions are identified, a SQL query is run to drop the suspicious transactions table, which you can see again using Athena. Got it? So fraud department does all these things using Athena, and our initial data is in S3 bucket. So let's go to plan. And the practice lab goals are going to be, we are going to run AWS Lambda function to generate a text file of fake credit card transaction, which I think happens here. Then create an Amazon Athena table from the exported text file. I think somewhere here it will happen. Then query the table for suspected credit card transactions. Suspected, I think here. Then review the locations of the saved query results, which will be on the staging bucket. And we are going to drop the suspected transactions table, which this is the part we are going to do as DIY. This is going to be quick because SQL queries always quick. Let's start the lab. All right, any lab files? Yes, we do have some queries lab files. Let's download them. I think they are downloaded to my system. Let's continue. Okay, which we just did it right now. Then we are going to Lambda. And again, concepts, pause the video and read this. I'm not going to read it because some of you already know these concepts. So when I read it, it is just wasting your time. So people who are not aware of this, pause it, read it. So let's click on that Lambda. Then we are going to just run the test. And in order to run, we have already learned in the previous video that we need to create a test event. And the test event is going to be something like that. And I don't think it takes any input, so you can pass empty. Or they are telling keep default. And then once run, because they are generating random data, it doesn't matter what input data you are giving. And you can see some random data is generated. And this Lambda also generates this data and writes it to the S3 bucket. So next step is we will go to the S3 bucket. Then we will check if the transaction is actually created or not. And then now we will go to Athena. You can read the concept here. So before doing that, let's go to the lab and finish it till then. And I will also walk you through the Lambda function if you guys are interested. S3, let's open in that separate tab. And they already have the Lambda function here. Okay, we already used the faker module in the previous project to create fake data, and they are going to use it here as well. And once again, lambda underscore handler will be executed when you run the Lambda, and whatever is under this function will be executed. So they are creating, I think, 6 columns, more than 6, I guess. First name, last name, they are getting fake names from that module. They will populate the file with these columns and fake data. Then they are writing it to temp directory on Lambda, and then they will be uploading that file to our S3 bucket, and the bucket name is parameterized. I think it is somewhere here, and they created it as an environment variable. And then the file or the key is going to be, or the file name is going to be data export.csv. And if we go and check the environment variables, okay, in just bucket, the bucket name is this, which automatically created and got populated here. So all we have to do is go to code, or you can even click there, test, and it will ask us to create an event. Let's say dummy event. It doesn't take any input. You can leave it as is, or you can just pass an empty one, that's fine, but you need to pass something. Then click test. Okay, I don't know why it took that long, but you can see the dummy data being created. I think we are only printing 5 rows, 9 columns, you can see. Now let's go to our S3 and see if that file is actually created or not. Okay, so I think are we already in that? No, I think this is the bucket, and you can see the file is created successfully. Oh, it has many records, that's why it took some time. That's about it. Now let's go to Athena. Athena, once we go there, you will click on query your data with TrinoSQL, then launch query editor. Okay, so before you run your first query, you need to set up a query result location in S3, which we can do by clicking edit settings, and then browse for our bucket, which is the staging bucket that we are going to use, or we can just click browse and keep this default whatever account ID. Then encrypt query results, choose enable. Then we are going to choose S3's default server side encryption, and then click editor and paste this. This is something that they already provided as the file which we downloaded. So let me go here, you can read the concept. In the meantime, let me get that file. Okay, these are the queries that they provided. Section 1 transaction table query, section 2 suspicious table creation query, section 3 and section 4. If you want, you can take a look at it, pause and look at it. Okay, let me take it here. So we are going to use the table to create the table on the transactions. And if you look at this query, the row formats are there. They are using Hive, Hadoop Hive. Properties are, we are telling it is delimited by comma, and then the location is our bucket name. We have to copy and paste it here. Table properties, is it encrypted data? Yes, encrypted, true. Basic stuff to creating an external table. Yes, they are telling us to change the bucket name, which we already know, so we will do that. Type it, review it, click it, run it, then I think it will create that particular table. Okay, you can see query successful, completed. And then once you have the table created, all you have to do is query it. You can see select star from, but you are loading those records into another table called suspected transactions. So how are you going to say that? If any transaction amount is greater than 5,000, they think it is something is going weird. I mean, that's true. Even if I use my card and go somewhere and swipe for that much amount, it will mark it as suspicion and I will immediately get a call. You might have experienced that as well. So you are querying from the transaction table where it is greater than 5,000 and putting the data into another table called suspected transactions. So what create table does is it will create the table as well as load the data based on the select. We call this create table select star from. Okay, so there are different ways you can create tables and load data, but this is one of the method. I think this SQL is already provided, so we will use that as well, and then run it. Then another table got created and loaded. So let's go ahead and do it before I forget the steps. Okay, we have the bucket. So let me copy the bucket name before I forget about this, and let me paste it in my notepad. Okay, that's done. Now let me go to Athena, and they asked us to use TrinoSQL editor. Once we are in the editor, what did they tell us? Go to edit settings so that we can choose the query location, results location. So when you run Athena, you will get results. Where do you want to store it? So under staging. That's it. I just want to store it here. Okay, can't I? Just pick this and get done with it. Okay, I need to select this one. Never mind. Choose it. Account ID, optional, encrypt query results, yes. And which one they asked us to use? Server side encryption S3, which is good. Done. Once we are done with that, let's go to editor. And here we are going to copy paste that SQL that we got from AWS, paste it, and this table is going to be named this one in the default schema. As you can see, there are no tables right now, and we are going to create these columns. Same thing, delimiter is comma, and that's the bucket. I just copy pasted it. Everything remains the same. Run it. Okay, completed. Now you can see the table got created. If you want to query it, you can query it by preview table, and you can see the data in that table, which is good. Now we have to create another table, which is the suspicions table. But what is the data that we are going to load into it? Any transaction from the transaction table greater than 5,000, then we mark it as suspicions and load that into the suspicions table. Simply do this, then it will create another table here. You can see suspicion. So this one will only have subset of records from this one, wherein the transaction amount is greater than that. So I can just click preview table. All the records will have the transaction amount greater than 5,000. Right? $70,000, seriously? That's definitely suspicious. Okay, so we catched up so far. So let's go back. Once that is done, and we are going to save. Okay, where is the first? Okay, we click on the plus, then we'll copy paste this code, which again we got it from CloudQuest team. Then we paste it, then we click on that, and then we choose save as. So I think they are just showing us how to save a query, which we can do that using that. Okay, I will remember it. And we are going to name it query name invalid security codes and that. Okay, let me go and do that because I have to copy paste it. So let's go here, remove that, paste it. What is this plus? Oh, this just adds the tab. And let's click on here, save as. Let me copy paste the name from here. Query name. Let me go back and the description I'm copy pasting it. That's fine. And the query is already here. So let's click on save query. I think the query is saved successfully. You can see it's named, and I think we will see that in a minute. Okay, cool. And let's see if there is anything. We can scroll down and you can see the concepts for it. Okay, once that is done, we can run it. And as you can see the results here. Okay, and once that is done, let's go back and we are going to add a filter. Not filter, actually this is a different query now. So previous one is invalid security. The previous query had invalid security codes. So let me go back and look at that. So here, any transaction amount greater than 5,000, I think we don't need to use this because all the records in suspected transactions are actually greater than 5,000. So this is useless, but they put it anyways. And card security code is less than 100. So anything that is less than 100, they think it is an invalid security code. Invalid security code, because of that reason this got cancelled or whatever it is. So that's why it's called invalid security codes. Now the last one, I think it's the last one, which is the transaction amount greater than 10,000 and the card type like diner. This is definitely a flag, right? Who will spend $10,000 in a diner, right? Unless you are throwing a party, but still $10,000, nobody goes to a diner and does that. So they want us to paste it, then save it as diner club suspected and then that one. So let's go back, replace, not here, we already have that. So let's click here, paste it, similar query. I can close this one, close that query, save as, copy, paste, copy, paste, save query. Okay, now we have it here. So let's run it and let's see. Oh, we have 11. And if you go, this is randomly, nobody spends 100K at a restaurant, diners club, etc. Right? So those are the results, which is good. And then let's click next, run. And we got the data. That is good. Because of the randomness of the results created by Lambda function, rule might look different than the screenshot. So that is expected. And what are they telling us right now? They are telling us to, I think, close all these tabs. And now we will go to S3. So when we ran these queries, results got saved, right, under staging. So we'll go to stagings bucket, and as you can see, using the query name, those results got saved here. You can read here more. Let's click on congratulations. That's it. I told you before starting this is going to be an easy one, because wherever SQL queries are involved, it's always going to be an easy one. Okay, that being said, let me go back here. We can close all these, close the query, close the query. Now let me go to here, not here, maybe here, or maybe I opened it in here. Okay, that's fine. Let me go to S3, and if I go to staging, oops, not that, staging, and okay, only one is saved, the other one is not saved. Maybe I have to go and run it again. Let's go. Did I close it already? Nah, I closed it. Okay, saved queries. I think this is not good. It's not created. Let's run this. I think I didn't run this. That's the reason. Okay. Now let me go back, refresh it. Okay, I have it here. So if I go here, it will create based on the timestamp. You can see the queries. One is the metadata, another one is the actual data file. I think for even the other one, it will be similar. Okay, so that's about it. But remember, we did get the suspected data, etc., but we didn't delete it from our actual transactions. That is our next DIY. That is what we are going to do. So the point of this entire project is what? How to use the data you have in your data lake and query using AWS. Okay, so drop the suspected transactions table. They want us to drop the table completely. Okay, because we have the records now, they want us to. Okay, that's fine. So let's go back here, and you have tables. One thing you can do is you can create delete table, and then okay, default the table and views will be removed from the Athena, so that will do it. I hope that is the one they asked us to drop it. And Athena database name, we need to go back here, and let's go to query location, saved. Database is default. What do you mean by database location? Oh, it is default. Database name, validate. I think they'll just check for the table on the default database, which won't be available. So I think it will be a success. Yeah, I think they just taught us how to create table, how to store queries, how to pick the location to store the results, how to drop table on Athena, and how to create external table on Athena to query S3 file. So that is interesting. I learned something. I mean, I already used Athena. There is more to Athena than this. If you have partitions created and if you want to refresh partitions and etc., you can do from Athena very easily. But pretty much that's it, guys, regarding this. Okay, so we are done with this project wherein we got transactions that are stored on data lake, and then we identified the suspicious transactions, and then we stored them, and then we dropped the staging table that we used. Excellent. This solution has made our fraud department very happy. I insist you accept a reward. Okay, I will pick this one. Hey, we got a new vehicle. Is that our new vehicle? Fireworks. Of course I like fireworks, but digitally, not in real. Okay, so what comes up? I leveled up 73. I think we are going to hit 100 by the time we finish this. And it's time for feedback. You all know what I will ask you guys. If you haven't subscribed, go ahead and subscribe for this channel. If you already did, then thank you very much. I really appreciate your support. But don't forget to hit the like, comment and share so that this video will reach so many other people and it will help them as well. So if you haven't done that, go ahead and do so. And you can support this channel by becoming a member and also giving super likes and etc. It's up to you. But if you want to encourage me and want me to add more content on this channel, please go ahead and do that. All right. So now you know what we have to do next. Do you guys remember this is what we placed in the previous project? Okay, that looks nice, right? That looks nice. Okay, so let's go ahead and zap some drones. Okay, where are you, dronies? What happens to the source data in S3 when queries are run in Amazon Athena? What happens? Nothing happens. The data is modified by Athena. The data is not modified by Athena. A separate copy of. Obviously, it is not modified by Athena. Nice. Okay, wait. I don't see any blue guys. Seriously? Do I have to go somewhere? Alright, I will go somewhere. Oh. Your name is written on this bullet, buddy. It fell right in front of me. A destination Amazon S3 bucket must be defined before running Amazon Athena queries. What do you guys think? True, false? We did pick the location. S3 bucket, we did pass it, but if we don't, where will it be stored? I think it is true. We can click the hint, but I think it is true. Yes, it is true. For a minute I thought there will be a default one, but no, we have to select it. If you don't select it and run it, it will complain about it. I think that's what happens. Okay, I think someone is coming from here. We can pick. What happens to the results of an Athena query that is saved? We just saw it. The results are saved to a common folder. The results are saved to a folder with the same name as the query. Yes. See? If we didn't do the project, we wouldn't have known that. But we did it, so we know it. Which statement in Athena creates a table from query results? Create table query from table from query. Obviously it is create table as, not create. Thank you. I will take that. You want to die in front of me? What happens to an Amazon Athena table and its data when a drop statement is used on the table? It's an external table. Only the structure will be dropped, not the data. The underlying data stays intact. The underlying data is removed. The table definition is select two. Yeah, these two. I always miss the select two and I do these questions incorrectly. I think I need some patience. Athena can query data encrypted by KMS. Yeah, of course it can. We kind of encrypted our data as well in this exercise. Should I zap this guy? Yeah, let's zap. Oh no, I missed one. Amazon Athena supports the ingestion of compressed data. I don't see why not. It all depends on when we create the external table, are we telling it if the data is compressed or not. I'm on a roll. Athena supports the ingestion of CS files. Yeah, we just did that. Maybe you should put instead of CS with JSON or not, because that's where people get confused. Okay, you are coming right towards me. Where does Amazon Athena store query results and metadata information? Where do you think? This? Query results and metadata, where do you think? Glue? No, it stores on S3 bucket. We have seen it, right? In the staging, we have seen two files, one for the schema and another one for looks like there is one here. Another one for data. I didn't expect this many questions from Athena. Athena attempts to read files specified by the user only when ingesting from an S3 folder. Attempts to read files specified by the user only when ingesting from S3 folder? What do you mean by that? Attempts to read files specified by the user only when ingesting. No. I think this is from the table creation. I think it is false. Yes. You specify the files to ingest when you create the table, not when you are querying. Amazon S3 feature automatically changes data storage tiers based on user specifications. Which one of them? Based on user. It's lifecycle configuration, isn't it? Yes, it is. I think we are done with the Athena questions. I think that's why it is asking us S3 questions. Okay, I think this is a good place to stop. I think this is a good place to stop. I hope you like this project wherein we learned about Athena. If you do, you know what to do. Thank you very much. Have a great day. See you in the next one. Peace out.